How's it, grade nines? So what I'm going to do now is I'm going to go through exercise 12.6, number 1 and 2. It's on similarity. Okay. So the first question here is saying, so we're given these two triangles and they're saying, prove that triangle ABC is similar to triangle RPQ. Now, I just want to highlight a few things here that they've given us. So they've put a little asterisk over here, and I'm just going to highlight that in blue. That means that that's equal to this asterisk over here. So those two angles are equal there. And then they've given us the little dots. So we know that this little dot is equal to that little dot over there. Okay. So how I'm going to do this, like I told you in the previous video, it doesn't make a difference how you write it initially. So I'm going to write it down the way that they've asked us. So I'm going to say here, in triangle ABC and triangle RPQ. Okay, and you remember for similarity, we need three things. So I'm just going to write 1, 2, and 3. So the first thing I'm going to say here is that A is equal to R, okay? And you can see that the A belongs in this triangle over here. So we know that angle A equals angle R. And our reason for that, they gave it to us, so it was given. The next thing I'm going to have a look at is we know that B is equal to P, all right? And B lies in this triangle, and P lies in that triangle there. So B is equal to P. Again, this was given to us. Okay, so this angle C must be equal to that angle Q now. Why is that? Because we have two pairs of angles that are equal already. So these two are equal to those two. Therefore, those two must be equal. Why? Because angles inside a triangle. So it would be 180 minus those two will be exactly the same as 180 minus those two there. So we can say here, third angle of triangle. Okay. Now what I do is I have proof similarity. I read it down like this. So therefore, triangle ABC similar to triangle RPQ. It's very important that you read it down like this, grade nines. And why was this? Because we proved angle, angle, angle. All three of those were angles. Okay, so now we've proved similarity for those two triangles. The next question, question B, is asking us, we have to find this X and this Y, okay? And how we prove that is by using our similarity. And the similarity, or the little fractions, like I showed you guys the other day, is from our little hops. And how we do our little hops, if you remember, we do this. So it's this over this. And that's why it's very important to get this part right, because you get your proportions coming out there. So we know that it's going to be AB over RP will be equal to, let's do the next hop. So that over that and that over that. So BC over PQ equals, do our last hop, AC RQ. Okay, and my reason for this is equiangular triangles. All right, that's from our previous video. Okay. Now what I'm going to do is I'm just going to fill in the information for this AB, RP, BC, PQ, AC, RQ from our two triangles over here. So AB is over here, which is 4 over RP. RP is over here, which is Y, equals BC is 3 PQ is 9. AC is X. RQ is 15. All right, so grade 9s, like the previous video, we are going to look for a fraction in here that has both numerator and denominator with numbers, okay? In other words, the top and the bottom of the fraction. And it's this one over here. Okay, so we can now set the other two equal to that one and then solve for that variable, either the x and the y. So I'm going to break it down. So we've got this first one, which is 4 over y equals 3 over 9. That's the one. And the other one is going to be these two over here. So we get 3 over 9 equals x over 15. Okay. So let's solve for this one. I'm going to multiply up by y. So I get 4 is equal to 3 over 9 times by y. To get this on the y on its own, we say 4 divided by 3 over 9 equals y, because that's the opposite of times. I'm going to just tip and times this, because we always tip and times with a fraction. So it's 4 times 9 over 3 equals y. From here, you can put it on your calculator. So you can say 4 times 9 over 3, and you will get your answer. So 12 is equal to y. So we got our y. Now let's do it with our x. To get the x on its own, I just multiply it by the 15. So we get 3 over 9 multiplied by 15 equals x. You can put that on your calculator. 3 over 9 times 15. And we get 5 is equal to x. So we solve for both the x and the y. All right, going on to question 2. Question 2 is asking us, or telling us that AE, this over here, and BD, that line over there, are straight lines. They've also given us that AB is parallel to DE. We have to prove that triangle ABC is similar to triangle EDC. Okay, so what I want to do here is I just want to highlight my two parallel lines just so that you can see where they are. So we've got this one and this one here. Okay, so I'm going to write it down how they've given it to us. So in triangle ABC and triangle EDC. And remember, grade 9s, this is not important how you write it out here. It's important how you prove it. Okay, so 1, 2, and 3. So first of all, I can see that angle B will be equal to angle D, and that is because of alternate angles. You can see your Z there. Okay, so we know that B is equal to D. Now B lies on this triangle over here, so it's angle B, and D lies in that triangle over there. And my reason for that was alternate angles. Whenever you use a parallel line reason, you must state which lines were parallel. So in this case, it's AB parallel DE. Okay. The next one I can see is A is equal to E. Again, we have alternate angles. There's your Z there with the parallel lines. So A lies in this triangle over here, equals E lies in this triangle over here. And again, it was alternate angles. And it's the same parallel lines. AB parallel DE. Now, grade 9s, you can say automatically that C1 is equal to C2 because of the third angle in the triangle. Or, if you guys see it, you can see that C1 and C2 are vertically opposite angles, so they would be equal, okay? So C1 lies in this ABC triangle, so C1 equals C2. C2 lies in that triangle. All I'm going to say here is I'm going to say third angle in triangle. Okay. Now, I'm going to read it down like this. Therefore, triangle BAC. Similar to triangle DEC. My reason, angle, angle, angle. So grade 9s, that's what I was telling you. It doesn't make a difference how you label it up here. What is important is how you prove it, because you read it down like this and then your similarity comes out over there. That is very important because you get your proportions coming out, your little fractions. Okay. Right. So question B. Determine the values of X and Y. So what I'm going to do is I'm going to use my little hop thing to get my fractions coming out. So my first hop, BA over DE. So BA over DE will be equal to AC, it's the next hop, over EC. AC over EC will be equal to BC over DC. BC over DC. My reason for this, equiangular triangles. Okay. I'm going to fill in now the information for our BA, DE, AC, EC, BC, DC from our figure here. So BA is from there to there, so that's 7 over DE is X equals AC. AC is this line segment over here, which is 5. EC is this line segment here, which is 6, equals BC, that over there, which is Y, over DC, which is this one over here, which is 10. Okay, so now I'm going to look for the fraction that has numerator and denominator. And again, it's the middle one. So I'm going to set the other 2 equal to that and then solve for the variable. So our first one would be this one over here. So we get 7 over X equals 5 over 6. The other one that we're going to get is 5 over 6 is equal to Y over 10. Okay, let's have a look at this one first. I'm going to multiply up by the X. So we get 7 is equal to 5 over 6 times X. I'm going to divide by the 5 over 6. So we get 7 divided by 5 over 6 equals X. Just tip and times that. Equals X. You can punch that on the calculator now. So 7 times 6 over 5. And you get 42 over 5. Equals X. Now grade 9s, don't worry if you're getting a fraction as an answer. That's perfectly fine. Okay. Over here, to get the Y on its own, I multiply up by 10. So we get 5 over 6 times 10 equals Y. We can put that on the calculator now. 5 over 6 multiplied by 10. And we get 25 over 3 equals Y. And we solve for the X and the Y. All right, grade 9. Thank you very much.